So, in our previous lectures, in our previous videos, we have seen some of the fundamentals of nanotechnology and some of the applications we have seen. So, in today's lecture, we should see where the nanotechnology and nanoscience, where we can fabricate the nano materials and all. So, where we can find the nanotechnology in India, right? So, IIT Mumbai is a premier organization in the field of nanotechnology, where we have Nanoscale Research Fabrication Center (NBRFC), which is governed by MHRD, and it is under the sense it is which is under Center for Nanoscience and Engineering at IISc Mumbai and IISc Bangalore, and also it is collaborated with IIT Bombay, right? So research in the field of health, environment, medicines are still on. So this nanotechnology was in India starting in 2001, right? So the government of India launched the Nanoscience and Technology Initiative, that is what NSTI, right? Then in 2007, the Nanoscience and Technology Mission 2007, Mission 2007 Nano Mission was initiated with an allocation of rupees 1000 crores, for a period of 5 years, right? So where in 2007 Nano Mission was established by the government of India, right, under the Department of Science and Technology, right? So the main objectives of this Nano Mission are the basic research promotion of basic research, right, and infrastructure development for carrying out front making research, right, and development of nanotechnologies in their applications, and human resource management, and human resource management, right, human resources development and international collaborations. Human resource development and international collaborations. So basically, the main outline of this is nanotechnology in India was first premier institute where the nanoscience, where the nano fabrication center has been developed, is at IIT Mumbai, and then IIT Mumbai and at Center for Nanoscience and Engineering at IISc Bangalore. So where we have this nano research fabrication facilities and all. Right, so the government has taken initiation. Right, India launched the Nanoscience and Technology Initiative in the year 2001. The government of India, and in 2007, Nano Mission was initiated. Nano Mission was initiated with funding some projects up to 1000 crores for a period of 5 years. And the main objectives of this mission are promotion of basic research, infrastructure development for carrying out front ranking research, and development of nanotechnologies in their applications, and human resource developments and international collaborations. So the international collaborations where we can do some of the experimental features, experimental techniques which cannot be done in India, can be collaborated with some foreign institutes and have collaborations and do whatever the fabrication techniques we can have, right? So the applications which we are left out with is our nanotechnology in mobile. Morphology and nanotechnology concept device developed by Nokia Research Center (NRC) Japan, and NRC Japan with collaboration with Singapore and with the University of Cambridge, that is UK. The morph will be a super hydrophobic, making it extremely dirt repellent. It will be able to charge itself from available light sources using photovoltaic nanograss covering its surface. So nanoelectronics also allows stretching. Nokia has envisaged that a nanoscale mesh of fibers will allow our mobile devices to be bent and folded, stretched and folded into any number of conceivable shapes. Right? So that is what nanotechnology in mobile. Nanotechnology where we can use nanotechnology in mobile phones. That is what morph, a nanotechnology concept device developed by Nokia Research Center and the University of Cambridge. So the morph will be a super hydrophobic, making it extremely dirt repellent. Dirt repellent. It will be a charge itself from available light sources using photovoltaic nano grass covering its surface. So nanoscale electronics also allow stretching. Nokia has envisaged that nanoscale mesh of fibers will allow our mobile devices to bend, stretch, and fold it into number of conceivable shapes. Right. So where the nanotechnology in mobile tech, where we can use nanotechnology in mobiles, that is mobile technology, we can use nanotechnology. And next is the nanotechnology in electronics. Electronics means electrodes made from nanowires. Electrodes made from nanowires enable that panel displays to be like flexible as well as thinner than current flat panel displays. Panel displays. This is what you can see here. So nanolithography is used for fabrication of chips. So this is what we use the nanolithography method. This is what nanolithography method, where we can write it, where we can write the pattern. Okay? That pattern can be written over here. So this is what the nanolithography pattern. The transistors are made of nanowires. So the transistors are made of nanowires that are assembled on a glass or thin films of flexible plastic. So e-paper displays on sunglasses and map on our windshields. Right. So this is what we can use the nanotechnology in electronics. Nanotechnology in electronics, in the sense, the nanolithography. Nanolithography is one of the essential fabrication technique in which we can write a pattern on a silicon wafer, or any other substrate, right? Any other substrate, right? So that is what a thin film. We can etch that particular silicon wafer to certain nanometers, and we can etch it to certain nanometers, and they can be used for fabrication of chip designing. So similarly, the transistors are made of nanowires. The transistors are made of nanowires that are essentially assembled on glass or thin films on a flexible plastic substrate, right? That is what flexible plastic substrate, that is what we can see here. And e-paper displays on sunglasses and map on a windshield. So these are the certain factors where nanotechnology can be used in electronics. Right? So nanotechnology in computer. So the silicon transistors in our computer may be replaced. The silicon transistors. So till today we have been using the silicon transistors, silicon chips in our computer systems. Right? The silicon transistors in your computers may be replaced by transistors based on carbon nanotubes. The silicon transistors in your computer may be replaced by transistors based on carbon nanotubes. A carbon nanotube is a molecule. In form of hollow cylinder. Carbon, as we have seen in our previous lectures, a carbon nanotube. This is what we see. This is what we can have, a carbon nanotube like this. It is in the form of a cylinder. It is in the form of carbon nanotube, in the form of hollow cylinder, with a diameter around a nanometer, which consists of pure carbon. With a diameter of around a nanometer, which consists of pure carbon. That is what we have seen when we speak about the one-dimensional, two-dimensional, and three-dimensional nanowire. So we can talk about the carbon nanotubes. There are two types of carbon nanotubes which you have seen. One is a single wall nanotube, and other is a multi-wall nanotube. So, and multi-wall nanotube can also be called fullerenes. Fullerenes is also the buckyball, and where we can have carbon 60, C60, right? C60 molecules also, right? So that is what a carbon nanotube is, a molecule in the form of a hollow cylinder. So hollow cylinder with a diameter of around a nanometer, which consists of pure carbon. So the next technology that is coming is nanorods. Nanorods, that is what is the upcoming technology in the displays techniques. Nanorods is upcoming technology in the displays techniques due to less consumption of electricity, and less heat emissions. So these are the advantages. This is one of the advantage for nanorods. Nanorods is a upcoming technology they are used in display techniques, light emitting display techniques, due to its consumption of less electricity, and and a less heat emission. The radiation that can be emitted from that nanorod is very less compared to the other. That's why nanorods is an upcoming technology in the display technique due to less consumption of electricity and less heat emission. And moreover, in nanotechnology, what we have seen in computers is the size of the microprocessor is reduced to greater extent. Size of the microprocessor, that means the processor size can be decreased. That is what reduced. The motherboard processor can be decreased. That is, the size of the microprocessor are reduced to greater extent. It means see here, if you can see here, this processor, it will be very less. The size of this is very less. It's coming to nano range. So that's why size of the microprocessor are reduced to greater extent. Researchers at North Carolina State University says that growing analysis of magnetic nanoparticle. Researchers at North Carolina State University states that growing arrays of magnetic nanoparticle called nanodots. So these are the nanodots where there is an array of nanodots, right? So array of nanodots, that is what magnetic nanoparticles. So researchers says that growing arrays of the array of magnetic nanoparticle gives rise to nanodots. Growing the array of magnetic nanoparticle is called nanodots. So Hewlett Packard is developing a memory device. Hewlett Packard is developing a memory device that uses nanowires coated with titanium oxide. One group of these nanowires is deposited parallel to another group. When a perpendicular nanowire is laid over a group of parallel wires at each intersection called memristor. Is formed. This means when a perpendicular nanowire is laid over a group of parallel wires at each intersection, a device called memristor is formed. A memristor can be a single component memory cell in an integrated circuit. So how can you define the memristor? Memristor can be a single component memory cell. In an integrated circuit. Memristor can be used as a single component memory cell in an integrated circuit. By reducing the diameter of the nanowires, researchers believe that memristor memory chips can achieve higher memory density than flash memory chips. Right? So that is the advantages of using high memory density. That means memristor, by reducing the diameter of the nanowire. Researchers believe that memristor memory chips can achieve high memory density than flat memory chips. So this is what we can bring out the difference between the high memory density devices and flash memory chips. That is what based upon a memristor that is formed. So magnetic nanowires made of an alloy of iron and nickel. Magnetic nanowires made of an alloy of iron and nickel are being used to create dense memory devices. So magnetic nanowires made of an alloy of iron and nickel and cobalt are being used to create dense memory devices. So the memory devices in magnetic materials, the magnetic materials that can be used as memory devices are nothing but cobalt, iron, nickel, and cobalt materials, right? So these are the materials where magnetic nanowires can be fabricated, right? Which can be used to create dense memory devices. So the chips produced by Intel Corporation before I-series processors are between 65 nanometer to 45 nanometer. So later, with the help of nanotechnology, with the help of nanotechnology, 22 nanometer chips were made, which itself is a milestone, which itself is a milestone, right? So initially chips produced by Intel before I-series processors were between 65 nanometer to 45 nanometer. Later, with the help of nanotechnology, 22 nanometer chips were made, which itself is a milestone. So based on these advantages, that is what we can tell when a perpendicular nanowire is laid over a group of parallel wires at which intersection a device is called memristor is formed. A memristor can be used as a single component memory cell in an integrated circuit. By reducing the diameter of the nanowires, researchers believe that memristor chips can achieve higher memory density than flash memory chips. So these magnetic nanowires made of an alloy. Alloy is nothing but a combination of different metals like iron, cobalt, and nickel, right, are being used as one of the fundamental for magnetic material, one of the fundamental materials for memory devices. So later chips produced by Intel before I-series processors were between 65 nanometer to 45 nanometer. Later, earlier, when the large-scale integrated chip or very large-scale integrated chips were produced by Intel Corporation, the series processors were between 65 nanometer to 45 nanometer, where the chip size, right? Later, as soon as the nanotechnology or nanoscience came into existence, with the help of this technology, the chips were designed around to 22 nanometers. 22 nanometers, the chips were made, which itself is a milestone. That means 22 nanometer, making a chip with a dimension of 22 nanometer is a milestone. So this 22 nanometer, making a chip design with 22 nanometer dimension with a milestone is due to the existence of nanotechnology, right? So there are some of the advantages of carbon nanotubes are the faster and smaller. Carbon nanotubes can be used to produce smaller and faster components. That is what carbon nanotubes can be used to produce smaller and faster components. This will also result in computers that consume less energy. This will also result in computers that consume less energy, right? So if you go for some of the advantages of carbon nanotubes are faster and smaller. Carbon nanotubes can be used to produce smaller and faster components. The components can be used, right? This will also result in computers that consume less energy. High speed and high capacity memory devices are produced by using the carbon nanotube, which is an added advantage for carbon nanotube, and allows circuits to be more accurate on the atomic level. Allows circuits to be more accurate on the atomic level. So these are some of the advantages of carbon nanotube. So some of the advantages where high speed and high capacity memory can be achieved by using the carbon nanotube, allows circuits to be more accurate on the atomic scale. So what are the other uses? Other uses where carbon nanotube are fundamentally other uses of carbon nanotubes are cutting tools made of nanocrystal materials. Such as tungsten carbide, titanium carbide, and titanium carbide are more wear and erosion resistant and last longer than their conventional counterparts. So cutting tools made of nanocrystal materials such as tungsten carbide, tantalum carbide, and titanium carbide were more wear and erosion resistant and last longer than their conventional counterparts. Silver nanocrystals have been embedded in bandages to kill bacteria and prevent infection. So silver nanocrystals have been embedded in bandages. If you see in bandages, where silver nanocrystals will be embedded into the bandages to kill the bacteria and prevent the infection. As soon as we fall down, we put some bandage. So as soon as the technology is developed, the silver nanocrystals have been embedded. Into the bandages to kill the bacteria and prevent infection. Nanoparticulate based synthetic bones formed by manipulating calcium and phosphate at the molecular level. So this nanoparticulate based synthetic bones, these are formed by manipulating calcium and phosphate at the molecular level. At the molecular level, we can manipulating the calcium and phosphate, right? So where we can have the strength of a bone that we use in our body can be manipulated. That means the strength of a bone can be increased at the molecular level. And next one is the aerogels. Aerogels are nothing but lightest known solid. Aerogels are lightest known solid due to good insulating properties. Due to good insulating properties is used in spacesuits, and are proposed to use in spacecraft. So aerogel's lightest known solid due to good insulating properties is used in spacesuits and are proposed to use in spacecraft. So these are some of the other uses of carbon nanotubes and nanotechnology, right? So that is what cutting. That is what. Just if you have a summary of it, cutting tools made of nanocrystalline materials such as tungsten carbide, tantalum carbide, and titanium carbide are more wear and erosion resistant and last longer than their conventional counterparts. Silver nanocrystals have been embedded in bandages to kill bacteria and prevent some infection. And moreover, and the next important other use is it can increase the strength of a bone, right? By having the calcium and phosphate at the molecular level, by manipulating the calcium and phosphate at the molecular level. So aerogels are lightest known as solid due to insulating properties is used in spacesuits. Aerogel suits and are proposed to using spacecraft. So possibilities. What are the possibilities for the future? Nanotechnology may make it possible to manufacture lighter, stronger, and programmable materials that require less energy to produce the conventional materials. So nanotechnology may make it possible to manufacture lighter particles or lighter materials, stronger and programmable materials that require very less energy to produce than conventional material, and that promise greater fuel efficiency in land transportation, ships, aircrafts, and space vehicles, right? So the future of nanotechnology could be very well include the use of nanorobotics, right? So the future of nanotechnology could very well include the use of nanorobotics. These nanorobots have the potential to take on human tasks. The nanorobots have the potential to take on human tasks as well as tasks that humans could never complete. Right? So nanorobots have the potential to take the human task as well as the task that human could never complete. Nanorobots have that efficiency or that tendency. The rebuilding of the depleted ozone layer, could potentially be able to be performed. Right? So that is what. So these are the possibilities for the future nanotechnology. Nanorobots. These are nanorobots that have potential application to take on human tasks as well as tasks that humans could never complete. The rebuilding of this depleted ozone layer could potentially be able to be performed. So these are some of the possibilities for challenging for the future nanotechnology. Right. So there could be a nanosurgical field to help cure everything from natural aging to diabetes to bone spurs. There could be almost nothing that could not be repaired eventually with the introduction of nanosurgery. So see here how a nanotechnology works. This is a star work replicator. These are the controllers. So this is a T. So where we can find the nanoform. This is how the nanotechnology works from bulk to nano, right? So this is what there could be an entire nanosurgical field to help cure everything from natural aging to diabetes to bone spurs. There would be almost nothing that could not be repaired eventually with the introduction of nanosurgery. So nanotechnology or nanoscience have broad applications, very good applications for the biomedical research and other related areas, right? So this is what we have this is what the tea maker is, and these are what the controllers. This is how we can make some replicators by using controlling the nanotechnology. So what are the disadvantages? What are the pitfalls of nanotechnology? Nanoparticles can get into the body through the skin, right? So the way in which nanoparticles can be injected to the body through skin, lungs and digestive system. thus creating free radicals that can cause cell damage. Right? So nanoparticles, when injected into the body, can damage the cells in our human cells. So that is one of the disadvantages of nanotechnology. Nanoparticles can get into the body through the skin, lungs, and digestive system, thus creating free radicals that can cause cell damage. Once nanoparticles are in the bloodstream, they will be able to cross the blood-brain barrier. Right? So when nanoparticles reach the bloodstream, they will be able to cross the blood-brain barrier. It's a blood barrier. The most dangerous nano application for use of military purpose is a nano bomb. The most dangerous nano application used for military purpose is the nano bomb that contain engineered self-multiplying deadly viruses that can continue to wipe out a community, country, or even a civilization. So that is what nano bombs, right? So nanobots, because of their replicating behavior, can be a big threat for grey goo. So these are some of the disadvantages of nanotechnology. That is one nanoparticle. These are some of the disadvantages of nanotechnology. That is what we call the pitfalls of nanotechnology. So in what way they are disadvantages? Once a nanoparticles are injected into the body, that means when nanoparticles are in the bloodstream, they will be able to cross the blood-brain barrier. And one of the most dangerous nano application used for military purposes is the nanobomb. Nanobomb that contain engineered self-multiplying deadly virus that can continue to wipe out a community, country, or even a civilization. Nanobots, because of their replicating behavior, can be a big threat for grey goo. So these are some of the pitfalls of nanotechnology, right? So there are certain advantages and disadvantages. So disadvantages comes as the pitfalls for nanotechnology, especially for medical uses and military uses, right? So these are some of the pitfalls of nanotechnology. Now, if you go for the fabrication methods, as we have seen in our previous slides, in our previous lectures, nanomaterials can be fabricated in two ways, namely the top-down and bottom-up. These we have seen in our previous lectures, namely top-down and bottom-up. In top-down approach, nanomaterials are constructed by removing existing material from large entities, that is from bulk to nano, right? In bottom-up approach process, materials and devices are built atom by atom or molecule by molecule or cluster by cluster. If you go for the synthesis of nanoparticles, you can see the block diagram, that is bottom-up process and top-down process. And top-down process includes the ball milling, plasma arcing, laser sputtering, vapor deposition method. So another process of synthesis of nanoparticles is bottom-up process. In bottom-up process, we have electrodeposition, solution phase reduction, Sol-Gel method, colloidal method. So while they have their own advantages and disadvantages of fabrication techniques. So if you come, so let us see what is a Sol-Gel method. So first we shall see what is a bottom-up process, and then we'll go for the other process. So that is what I'm telling you again. Nanomaterials can be fabricated in two ways, namely top-down and bottom-up. In top-down approach, the nanomaterials are constructed by removing existing material from the large entities. In bottom-up approach, materials and devices are built atom by atom or molecule by molecule or cluster by cluster. So synthesis of nanomaterials can be done in two ways, either by top-down approach, top-down process, or bottom-up process. So top-down process is ball milling, plasma arcing, laser sputtering, vapor deposition method. So this vapor deposition method, physical vapor deposition, chemical vapor deposition methods are there. We shall see them in the next coming videos, and we shall see. And the other one is a bottom-up process. In bottom-up process, we have electro deposition and solution phase reduction, Sol-Gel method, and colloidal method. Right. So what are the advantages of this process? Let us see what are the advantages of this process. What is the top-down approach and bottom-up approach? As we have seen that these top-down approach and bottom-up approach are the two important fabrication methods. And we shall see what are the advantages and disadvantages of each approach. So if you go for top-down approach, the advantages are large-scale production deposition over large substrate is possible. In a top-down approach, the advantages are large-scale production. That means you can large-scale production deposition over a large substrate is possible. Deposition for a larger substrate. If you take a glass, if you want to deposit a metal on that particular substrate, it can be done. That is what top-down approach. That is one of the advantages. Chemical purification is not required. Here, one of the advantages of a top-down approach is chemical purification is not required. So if you see what is a top-down approach is, top-down approach is nothing but ball milling, plasma arcing, laser sputtering, and vapor deposition method. So when we talk about these methods, they have certain advantages. That is, large scale production, deposition over a larger substrate is possible. Chemical purification is not required. And other is bottom up approach. Bottom up approach. What are the advantages of bottom approach? Ultra fine nanoparticles, nanoshells, nanotubes can be prepared. Ultra fine nanoparticles, nanoshells, nanotubes can be prepared. So deposition parameters can be controlled. Deposition parameters can be controlled by using bottom up approaches. So narrow size distribution is possible. Narrow size distribution is possible, which is around 1 to 20 nanometer. And advantage, one of the advantages of bottom up approach is this bottom up approach is a cheaper technique. One of the it's not that much expensive. So bottom up approach is a very cheap technique. And if you go for the disadvantages of top down approach, we have broad size distribution. Broad size distribution, that means deposition can be from 10 nanometers to 1000 nanometers. So varied particle shapes or geometry. Control over deposition parameters is difficult to achieve. That means deposition rate, the rate of deposition to achieve, to control the deposition rate is difficult in top-down process. Right? So that is one of the disadvantage. And other is impurities. Impurities, stress defects, and imperfections get introduced. That means when we go for top-down approach, like ball milling, that is what we have seen in our ball milling and plasma arcing, laser sputtering, vapor deposition. So the deposition rate cannot be controlled. Deposition rate cannot be controlled. Rather, it will be depending upon a parameter called yielding parameter. That is why we call it as yields. That is why it is we call it as a yield. So it depends upon a new parameters like yielding parameter, like sputtering yield, like deposition milling, ball milling. So these are the different yielding parameters. They depend on the yielding parameter, right? So to get the maximum yield we have to control the rate of deposition. That is not possible in case of top-down process. That's why when we try to control the deposition rate, then impurities and imperfections come into play and make the deposition not comfortable for the experimental purpose. That's what impurities like stresses, defects, and imperfections get introduced, and it is an expensive technique. Top-down approach like ball milling, top-down approaches like ball milling, plasma arcing, laser sputtering, vapor deposition method. These are some of the expensive techniques. They're expensive techniques when compared to bottom-up process. Bottom-up process is a cheap process. But here the vapor deposition method, laser sputtering, these are the different equipments which are we need to buy each and every equipment. So to buy each and every equipment becomes very expensive, right? And moreover, the yielding parameters are to be controlled. That means the rate of deposition of the material, it should be strictly depending upon the yielding, right? Should be yielding. So when we try to maximize or control the rate of deposition, then some unwanted particles come in to get introduced. So that is what when some unwanted particles come and introduce, then we get some imperfection in the deposition rate, or imperfection in the deposition what we need in top-down approach. So that is one of the major disadvantages in top-down approach. So if you go for bottom-up approach, so we can see that we have seen that advantages are there. Ultra-fine nanoparticles, nanoshells, nanotubes can be prepared, and deposition parameters can be controlled in bottom-up approach. Narrow size distribution is possible. That is around 1 to 20 nanometer, and the technique is very cheap compared to the top-down process. So some of the disadvantages of these bottom-up approaches are this large-scale production is difficult. Some of the disadvantages is large-scale production is difficult. Large-scale production is difficult, and moreover, chemical purification of nanoparticles is required. So these are the disadvantages. Large scale production is difficult, and chemical purification of nanoparticles is required. So what is this chemical purification of nanoparticles is? If you see the previous slide, see, we have some bottom-up process. We have electrodeposition, solution phase reduction, sol-gel method, colloidal method. So all these methods come under chemical purification. So they require some chemical reagents. They need to undergo some chemical reagents for synthesis for synthesis of the particle, for synthesizing of the particle. For synthesis of nanoparticles, for synthesis of nanomaterials. So that's why this problem, this chemical purification nanoparticles is required. And if you go for this disadvantage, large scale production is difficult. Large scale production is difficult when we speak about the disadvantages, right? So these are the major disadvantages and advantages, and disadvantages and advantages in bottom-up approach and top-down approach. So out of this top-down approach and bottom-up approach, we can go for, of course, both are advantages to their extent, and both are disadvantages to their extent. But when for fabrication of the nanomaterial, in liquid form or in chemical form, a bottom-up approach is what's suggestible compared to top-down process, bottom-up approach. Because in top-down approach, we have different experimental techniques. We have some different experimental instruments or instruments like what is this? Like plasma arcing method, laser sputtering method, that is RF sputtering, or we have this one DC magnetron sputtering and vapor deposition methods, vapor deposition like electrodeposition, vapor deposition like thermal evaporation and all. So these are all the different experimental techniques which is not that much commercially available, because they are very costly compared to bottom-up approach, right? So these are some of the advantages of this process, top-down process and bottom-up approach, right? So let us see what is the sol-gel method, because this is one of the bottom-up approach, forced bottom-up process. That is what bottom-up approach. In bottom-up approach, we have a method called sol-gel method. In bottom-up process, we have a method called sol-gel method. So let us see what is this sol-gel method is. So four steps are used in sol-gel method. First one is preparation of solution, preparation of sol, that is what we call it as preparation of sol. The starting materials used in the preparation of the sol are usually inorganic metal salts or metal organic compounds such as metal alkoxides. Another is preparation of gel. A typical sol-gel process, the precursor is subjected to a series of hydrolysis and polymerization reaction to form a colloidal suspension known as gel. Another is drying and purification. In this step, heat treatment is given to the gel emulsion to dry it up to the level necessary for further processing and product formation. There are different techniques. We can fabricate the particles of film of desired shape and size. So these are the four steps. That are generally involved in sol-gel method. That is preparation of solutions, preparation of gel, right? Preparation of gel, drying and purification, and other is product formation. So these are the four steps that are used in sol-gel method. So preparation of gel in the sense, preparation of solution, the starting material used in the preparation of the solutions usually inorganic metal salts. So what are the materials that we use? They are generally the inorganic metal salts or metal organic compounds such as metal alkoxides. So these are the one of the essential material or essential solutions that are used for preparation of solution. Next is preparation of gel. So a typical sol-gel process, the precursor is subjected to a series of hydrolysis and polymerization reaction to form a colloidal suspension known as gel, right? So other one is drying and purification. In this step, heat treatment is given to the gel emulsion to dry it up to the level necessary for further processing. That means we have to heat treatment. That means annealing is given to the gel emulsion to dry up to the necessary level for further processing. And then finally, the product formation. So that means product formation, different techniques we can fabricate the particles or films of desired shape and size. So these are the 4 steps that are generally involved in soil gel method. Right? So the remaining we'll see in the next video. Okay. So these are the 4 steps that are used in soil gel method.
Like, share and subscribe. Hit the bell icon for more updates.